Hey, this is going to be our last lesson in our geology unit on the study of the earth and rocks. And so we are ending with weathering and erosion, which we've already talked about some when we learned about sedimentary rocks and whatnot, but I'm going to dive a little deeper into what these two words mean. So first off, we've been talking about this word sediment and that sedimentary rocks are made of it. But what is sediment, right? I'm going to review that because it is directly related to our weathering and our erosion. So sediment are the tiny little bits of rocks that have broken off the bigger rocks. So really it's just a bunch of little tiny rocks. It's like sand because sand is a bunch of tiny little rocks. You could probably classify it sand as sediment or as a type of sediment, but that's pretty much what it is. So the question is, how does this happen? How are bigger rocks broken down into those tiny rocks to make sediment that will then eventually make sedimentary rocks? And that is through the process of weathering. Weathering is the breaking down of bigger rocks into littler rocks. And those little bits of rocks are what sediment is. Now there's two types of weathering that I'm going to expound on here. For the most part, what we've been talking about in class, the breaking of the bigger rocks into littler rocks, is mostly this first type of weathering called physical weathering. And so physical has to do with the kind of like outside physical parts of it. So obviously rocks are always enduring the weather, right? Because they're outside. It's not like they can move around or put up an umbrella. So rain, snow, and ice will weather rocks and break them apart over time. Hence the word weathering. The weather is what's breaking them apart. That's why it's called weathering. Extreme temperatures, because again, they're also outside. They can't cool themselves off or whatnot. Can also break down rocks. And so you don't get confused. Physical weathering can also be called mechanical weathering. You pretty much will see it as physical weathering. But I didn't want you to be thrown off if you see mechanical weathering and be like, well, we didn't talk about that. What does that have to do? Machines? No, it's the same thing. Just breaking down via the outside of the rock. So let's think about this. When it rains, all the little raindrops will fill any holes or cracks that are already in a rock, and then overnight it has the potential to freeze. And if that water freezes, it'll expand some. So if you're picturing the raindrops are in a crack in a rock and it freezes and expands, what's going to happen to the rock? The expanding water, aka ice, because it's frozen, will crack the rock. For example, in our picture, right? So water filled up the crack in the rock, the ice or the water froze into ice, right? And it pushes it apart just that little bit more. And this process is actually called frost wedging, which frost, ice, weathering, wedging, okay, wedging it apart. It's an example of weathering. As you can see in our example picture here, eventually, as this keeps happening over and over and over again, you can see where that kind of front section of rock on the top there, where the arrows are pointing like out and up, eventually the ice will get underneath that part and get the right side of it far enough away that that part will just plop, fall right off this bigger rock. Now that's not sediment, right? Because it's not really tiny, it's still a big chunk of a rock, but it's the first part, and then that rock will start to chip into tinier pieces. So this isn't an immediate process by any means. It's an over time, but this is how we get sediment. Okay, and the temperatures. So we went over the kind of the physical, like frost wedging as an example of ice breaking apart a rock, which is also kind of water. But I also mentioned extreme temperatures can weather rocks. So pretty much if the temperature is constantly going up and down, it can break rocks apart too, because when a rock heats up, it'll expand some. This is why in like concrete bridges, you will have those little like certain points that you go thump over in your car, because they're like these grates in the middle of the concrete. It's there because on hotter days, the concrete will expand some, and then when it cools back down, it'll contract some. So it's to keep the bridge together, obviously, with those little fluctuations and help the concrete from not breaking. But yeah, so when a rock heats up, it'll expand slightly, just a little bit, not like we would notice, but it gets a little bit bigger. And then when it cools back down, like at night or whatnot, it'll contract a little bit. Again, not that we would notice, but it'll shrink just a little bit. That's what contract means. It'll shrink. Okay, so if you do this enough, going back and forth, right, it'll cause the rocks to break into smaller pieces, because a rock is not made to go expand, shrink, expand, shrink, expand, shrink, expand, shrink. I mean, it's a hard rock. It's not supposed to be like flexible and do that over and over again. So when that happens, that causes the physical weathering for it to then eventually just break, because it can't constantly go back and forth between expanding and contracting with the temperature. All right, our other type of weathering, our second type, which is, I would say, less common, and you wouldn't have to know it as much, but just to cover our basis, it's called chemical weathering. So this is when the chemicals found in the water can weather the rocks as well, because they end up having chemical reactions with the minerals in the rocks. So for example, the oxygen and hydrogen, which makes up water, right? H2O, hydrogen and oxygen, they can have that reaction to minerals in a rock. In the background picture, I have an example of chemical weathering where they used like holes per se in this rock. These divots, they were created by what we call acid rain, which is kind of what it sounds right, where it's more so the acid part comes from like our steam, and not steam, but like the smoke and stuff that you see coming out of industrial buildings, that kind of stuff, any kind of air pollution kind of stuff, can cause acid rain. Now, the acid is not acid that like will burn through your skin or whatever. No, we would be fine in acid rain, like it's just any other rain. But those chemicals or those added parts to the rain will chemically weather rocks. Another example, oxygen will react with iron. So if there's any iron in a rock, it'll turn into iron oxide, which you guys know as rust. So it's pretty much rusting the rock if there's iron in it. And so iron oxide, or the rust, is weaker than like normal iron. And so it'll make the rock overall weaker and weaker until it will break apart, because it doesn't have that strong iron parts of the rock to like hold it together. We made it weaker by adding the water and the oxygen, turning that iron into rust, so that eventually the rock will break apart. Okay, so our next topic, erosion. So those are our two types of weathering. That's breaking the rocks apart. Erosion is our process of moving that sediment, moving those broken pieces of rock somewhere new. So once the little sediment bits have weathered off the rock or broken off the rock, erosion carries those pieces away, whereas the weathering is changing that rock, because weathering is actually breaking it. It's changing the original rock. Erosion is just carrying those broken bits away. That's how they're different. And so many natural agents, many types of weather, will erode rocks, like wind, rain, and ice, similar to what will break them down as well. And so those little bits of rocks can obviously easily be blown elsewhere by the wind. That's how the wind erodes the pieces. They blow them to a new spot, and that's, yeah, when they blow those little pieces of rocks somewhere new, That can also work in the weathering, the physical weathering part of hitting the other rocks, and just like taking sandpaper to smooth something out, you take these little bits of sediment, which are like sand, and you blow them against a rock, it's gonna weather it. And they can also be easily washed away by the wind, or I mean by the rain. Sorry, we just blow it away with the wind. Can be washed away by the rain, or taken away by water if it's near a stream or river itself. So here's our part in it, because humans always have a part in it, right? We've been learning that humans are a problem to our natural environment. We cause erosion. So as we develop land, we create erosion. And by developing land, I mean like building our houses and things like that, taking down the trees to build the houses. Through that process of developing land, we cause erosion. So when logging trucks come and take the trees from a hillside, okay, it can cause a lot of what we call soil erosion, which is bad because that means the soil is just being taken away by wind or rain or whatnot, where we need that soil. And because that soil is going to go into the water sources and make it all dirty, and just add a lot of extra stuff we don't need in our water, right? Because eventually it'll come back around to our faucets. Now we have filters and things, but in general, that's the idea. So the trees are actually really important because they hold the soil in place and stop soil erosion. Because think about the trees being in the soil, well, their roots are everywhere, right? Because that's parts of our plant way back in the very beginning of our year, okay? The roots hold the soil together so it can't go anywhere. The wind's not going to blow it away, and it's not going to wash away because it's being held together by the roots. So without the trees or without the roots, the soil can just be washed away by rain, blown away by wind, and cause other problems. Last but not least, this word we haven't talked about yet, deposition, is pretty much, you'll see, like it goes to our sediment we haven't talked about, but it's fast moving water will pick up and carry our sediment, right? We already know that because that's part of the way the ocean gets salty. So river will pick it up and carry it that way, okay? But once all of the fast moving water, once it starts to slow down, because water ebbs and flows, it's not the same speed all around, okay? When it starts to slow down, what's going to happen to the sediment that water was carrying? Well, if the water is going slower, it's going to start dropping sediment, okay? So the sediment is going to sink to the bottom and collect there. This is how we're getting our sedimentary rock, right? Because the sediment is going to start piling up on itself in layers at this spot where it's slower, okay? And then they get compacted into what becomes sedimentary rock. But this process is called deposition, which is sediment being carried somewhere else. So sediment that's eroding, but then it's being dropped off in this new place to then kind of form our sedimentary rocks. Dropped off or deposited, hence the name. I know we pronounce deposition differently, but if you look at the word, you see deposit, shun. So if you need to pronounce it incorrectly, because deposit means to drop off, or like deposit in a bank, you're putting your money in there in one spot. So deposit, shun is the same thing. It's dropping off or depositing that sediment in one place where it gets those layers and forms that sedimentary rock after it's but so big. So that was our lesson on weathering and erosion. Like I said, you should have known some of it by now because we've talked about it a few times with our sedimentary rocks and whatnot. I know deposition was new, but it goes right along with them. I don't think it should be super hard to know the difference, but that's the end of our geology unit. And I'll see you for our next topic.